Hello students, how are you? I hope you are doing good. I am also doing. So here we are with our lecture number 7 on wave on stream or simply the wave mechanics. So till now we have covered what we have covered. Let me brief you about that. So in the yesterday's class we have did with the principle of superposition, interference and reflection of waves. Okay. Now what is the principle of superposition? So whenever we have two waves, their resultant wave has an amplitude is the summation of individual amplitude of each and every wave. So suppose in a system we have two waves, this one and this one, okay? And if we superimpose them, then how to be superimpose two waves? Firstly, we have sent this wave, then anotherly, we have sent the other wave. So what when they meet, what is the resultant amplitude that is given by the principle of superposition? And that is nothing but I will brief you by the PPT. So this wave we have seen when two waves we have generated, when they meet, the amplitude will disturb. Okay. So what is the effect on the amplitude that will be given by this equation? These are two wave pulses. These are the amplitudes y1 and y2. So according to the principle of superposition, at a particular point in the medium, the resultant displacement produced by a number of waves is the arithmetic sum. This is important. Arithmetic sum, which means you have to take the sign also. Sum of the displacements produced by each of the wave. So see, here we have two wave pulses, y1 and y2 are the individual amplitude of both of them. So when they meet, what will be the resultant amplitude? It is y1 plus y2. Now, these 1, 2, 3, 4, 5, 6, 7 are the particles, and to reach from 1 to 2, we will take exactly 1 second. So in this process, at t is equals to 0, we have generated a pulse. First is the upper side, second one is the lower side. They are moving towards each other. Now, if I talk about the resultant amplitude, so after t is equals to 1 second, they will move further. At t is equals to 2 seconds, they meet up. Then what will be the resultant amplitude? We will take that y resultant will be y1 plus y2. Since y1 is in upper side, y, and y2 is in lower side, so it will be taken as negative y. So y1 plus y2 will become y minus y. The resultant amplitude here will become 0. Now the interference. What about the interference? Interference is just the application of superposition. Addition of two waves by superposition principle that generate a new wave pattern. This process is termed as interference, although interference itself is a part of superposition. So when the superposition is happening, we will have introduced a new wave pattern because amplitude is disturbed. That process of making that wave pattern is termed as interference, and that is happened and that is possibly done by the principle of superposition. So we have two types of interference here: constructive interference, destructive interference. Based on the previous example, if I conclude to you, the resultant amplitude in the previous case is decreased almost zero. So in this case, when the amplitude of the resultant wave pattern is zero or minimum, that case will be the destructive interference. The name itself suggests the destruction of the energy, destruction of the wave. But when two waves are traveling in same direction with same amplitude or whatever the amplitude is, but the direction is same without any phase difference. Okay. So in that case, what we have the principle of superposition, and by that, the magnitude of the amplitude of the resultant wave will amplify. Okay, and that will be the maximum value. So in that case, when the new wave pattern that we have generated by the interference of two waves, if the resultant amplitude takes its maximum value, that particular scenario will be considered as constructive interference. Okay. So this y1 is equals to a sine kx minus omega t. It is a wave traveling in negative to positive x direction. So this wave will be defined like this. At x is equals to t is equals to 0, sine will become 0. So y1 will become 0. That means the wave has started from origin with 0 amplitude. The particle that is present at origin has 0 amplitude at that particular instant. And what is that instant? T is equals to 0 and the position is x is equals to 0. Now, if we take another wave, this one you can take. If we take another wave y2, y2 has a sine kx minus omega t plus phi, which means the wave is same, traveling in the same direction, but it has a amplitude, sorry, it has a phase difference of phi, due to which the wave pattern of this y2 will disturbed, because when y1 takes its maximum value, it is not say, it cannot be said that ki y2b will take its maximum value, because y1 is minimum at x is equals to t is equals to 0. But if you put x is equals to 0 and t is equals to 0 in y2, then is it becoming 0? Is it becoming minimum? No, it become a sine phi, and all the value now will depends on the value of phi. Okay, so phi here is the phase difference due to which the initial status of the wave has been changed. And if the initial status has been changed, all the status, all the points will change its amplitude. Okay. Now this wave is somehow what you can compare it. It has started from here. So it has started somewhat later. Okay. This is, let's say, at t1 time, it has an amplitude y2. What is the resultant? This wave is the resultant one. If we superimpose them. So at any particular instant, for this new wave pattern, any particular instant, we will take the resultant amplitude as y1 plus y2. Now, this y1, this is y2. According to the principle of superposition, we will add them. We will have covered it in the previous lecture, so I'm moving it rapidly. So if you apply the formula, you will get a wave pattern like this: 2a cos phi by 2 sine kx minus omega t plus phi by 2. And this probably, this exactly a function here, y is a function of ax plus minus bt, and that is satisfying the condition to be a traveling wave. Okay, which magnitude is 2a cos phi by 2, which means it depends on phi, value of phi, and phi is fixed for each and every wave. If you write the displacement equation of that wave, you will define the value of phi initially. Okay, so we can say that 2a cos phi by 2 is the amplitude which has different value for different values of phi. Now we are only interested in two values. One is the minimum, one is the maximum. When will this 2a cos phi by 2 will be maximum? It will be maximum when cos phi by 2 will maximum. It will be minimum when cos phi by 2 will minimum. Okay. So only cos phi by 2 is a place of interest that we have. So if the amplitude of resultant wave will become maximum, that particular wave, that new wave pattern will be a constructive interference wave pattern. Okay. So for constructive interference, this A should be maximum, which means 2a is equals to 2a cos phi by 2. Why 2a? Because the maximum value of this 2a cos phi by 2 will be 2a. Because cos phi by 2 will become 1. The maximum value of this will 1. And it is only happen when cos phi by 2 is equals to 1. So phi by 2 is here is 0 plus minus pi plus minus 2 pi. So in the previous lecture, I have told you that phi here is the even multiple of pi for constructive interference. So let me write this thing. Pi is the even multiple of pi for constructive interference. Constructive interference. No. For destructive interference, opposite to that, we have did. So what is the opposition of that? If a wave is new wave pattern is achieving the maximum amplitude for constructive interference. So for destructive interference, it should take the minimum value and which is 0. So this wave, you can say it is starting from the upside, it is started from the downside. So they have a phase difference here for value of pi. So here the amplitude will become 0 because this is negative, this is positive. So they will cancel each another out. And finally, we will have a plane wave here. This is not, we can say a wave also. This is the plane stream. Okay. So for destructive interference, this A should be minimum, and this A should be minimum when cos phi by 2 will be minimum. Cos phi by 2 has a minimum value of 0. So cos phi by 2, if you compare it with 2a cos phi by 2, cos phi by 2 is 0. So cos has a value of 0 at even multiples of, sorry, odd multiples of pi by 2. So if you take here, so the phi will be, if you see, phi here will be the odd multiple of pi. So for even multiples of pi, we have a constructive interference. For odd multiple of pi, we have a destructive interference. So I will write here, note. So note it down. For odd multiple of pi, we have destructive interference. Okay. Odd multiple of pi के लिए we have a destructive interference. Even multiple of pi के लिए we have constructive interference. Now, the reflection of wave. So reflection of wave में we have talked about that wave can reflect from a rigid boundary also and from a free boundary also. ठीक है. So if I consider that this is a wave which is generated by this point source, okay. So when wave is strike with a rigid boundary, you can see that boundary here is not, it cannot move. So the wave is invert itself, if you will see. Firstly, it is going upside, then after reflection, it is going to the downside, which means that it has a phase difference of pi because it had just opposite to this, and that angle should be pi. Firstly, it is going in this way. After reflection, it is going in this way. So this wave has inverted at an angle of what it. So when a wave hit with a rigid boundary, it reflect back with a phase difference of pi. But what will be the same value here? If you will see, what is same? Just a second. If you see, the amplitude is not disturbed. Okay. So amplitude remains same. Whatever the amplitude of the incident wave after reflection, the amplitude will remain same. But the phi, which is the phase difference, that will change. The reflection of wave at rigid boundary. So as the pulse arrives at the resident, it exerts a force on the resident. So what is that thing? Let me introduce to you. Suppose this is the incident wave pulse which is coming. And when it strikes the boundary, the string wants to move up. It wants to follow the same pattern. So it wants to move up. So it exerts a force on this boundary. But boundary is rigid. So this cannot move up and down. This boundary. So what the boundary will do, in opposite to that, it will apply a reaction force on the wave pulse in the downside. Okay, with the help of by the Newton's third law. So this is the force applied by the resident. So this generates a reflected pulse that differs by a phase angle of pi. Now, so if the equation of incident wave is given by y is equals to a sine kx minus omega t, then equation of reflected wave yr is equals to a sine kx plus omega t plus pi. Why it is plus? Because now the wave is moving in negative x direction. If you consider this direction to be positive x, this direction would be considered negative x, and this reflected wave pulse is moving in negative x direction. So this will become kx plus omega t plus pi. Now, but when the boundary is free, so what will happen? You can easily guess. There is nothing to resist the force. So it will move in the opposite direction, but without a phase change. And if you will see, the magnitude is also same. Okay. The equation now will change to, if you will see this, there is no restriction now. So the same pattern it will follow, but in the opposite direction. So reflected wave will be given by this equation, a sine kx plus omega t, where a is the magnitude which is not been changed. A and a is same. So what will be the shape of the reflected pulse for rigid boundary, for free boundary? This is the question. So if this is a rigid boundary, firstly we will talk about case 1 is rigid boundary. So we know that when this square pulse will travel near to the boundary, what will happen? The boundary will invert it and send it back if this is a rigid boundary. So the reflected wave pulse will be like this. And for triangular one, it will be like this. But if it is a free boundary, case 2, if it's a free boundary, then what will happen? They will travel to this direction, but there will be a no change in the phase, and it will travel back with the same amplitude, same velocity. Okay. Same for the triangular pulse. So reflected after reflection, it will move in the opposite direction. This is the only difference. The direction is only changed, not the amplitude or the phase angle. Now, refraction of waves. This is the reflection. Now, what is the difference between them? Reflection and refraction. Reflection may we have the string, we have generated a wave pulse. It strike with the boundary, interact with the boundary, and completely it reflect back. But in the refraction, there is some part of the wave will transmit to the another system, another boundary. Okay. And some part is reflected back. So when there is a partial reflection, that is termed as refraction of wave. Okay. And that you will see in the optics also. So refraction of wave. So if the boundary is an interference between two different elastic media, like one is a heavy string, heavy rope, another one is a very light rope. So these two at the boundary will form a elastic medium, different elasticity medium. Okay. Then a part of the incident wave is reflected because at some portion the lighter one will behave, sorry, the heavier one will behave as a rigid boundary. but it is not tied, it is not fixed. So we have a condition for free boundary also. So some of the part will transmit to the another boundary, another system, and some of the part is reflected back. That phenomena is termed as refraction of wave. So first of all, first case when we will take when a light string is attached to the heavier string. Okay. So in that case, what will happen when we send the incident pulse? It will strike the boundary. Now what will happen? This heavy rope is heavy to pull, so it is resisting somehow. Some of the portion will resist, okay, because it is high elasticity. So because of that, this boundary now will behave partially a rigid boundary. So this portion will travel back, reflected back, but with a phase change. And some portion, because this end is not fixed, this end can move. So some portion will transmit to the another system. But if you will see, again, if you will see, the amplitude now has been changed because energy is constant. Okay, it is carrying some of energy, some of it has transmitted to the heavier rope, some of it has taken, not the fully one. So amplitude will decrease of it. Okay, so the heavier string will behave as a rigid boundary. Now the second case, when the heavy string is attached to the light string, in that case, what will happen? You can easily guess. This cannot resist it. So there will be a simple pass of this and there will be a no phase change. Okay. So this light string will behave here. This at this portion, this light string will behave as a free boundary because it cannot resist the heavier string. Free boundary. And since there is no restriction also, so some of the portion will travel to the lighter rope and some of the portion will travel to the heavier rope. Okay. So here the reflected pulse is in same phase because lighter end behaves as a free end. So if you will see, this is this is moving in this direction, moving with amplitude in positive way. And when it reflected, although the amplitude is disturbed, but it is moving with the opposite, it is moving without a phase change. Okay. So you can note this point that reflected and transmitted, both pulse has a smaller amplitude than the incident pulse in both the cases. In the previous case, if you will talk about, in this case also, and in this case also. Okay. Now, if I talk about the summary of this chapter, so first of all, we have seen the principle of superposition. What is that? Principle of superposition says that when two waves combine with each other, so the resultant amplitude is given by the uh, arithmetic sum of the displacement of two waves. Okay, y1 plus y2. Now, based on that principle of superposition, the new wave pattern will be followed. That new wave pattern will be judged by the this interference phenomena. Okay, so this phenomena, when two wave pulse traveling in opposite direction meet each other and there will be a destruction in the amplitude, so there will be a no new wave pattern will form. That phenomena is termed as the interference. Okay, and there will be a phase difference of 4 constructive interference. Now phi here is 0 plus minus 2 pi plus minus 2n pi. Okay. For destructive interference, amplitude A is minimum, that is phase difference for destructive interference. I have told you that for constructive interference, phi will be a even multiple of pi. And for destructive interference, there will be a pi will be a multiple of what? Odd multiple of pi. 2n pi and 2n plus 1 into pi. Okay. So when a wave is get reflected at a solid boundary, so it reflect back. From solid boundary, it is reflecting back, but with a phase change, with the shape change of the incident pulse. And with how much amount of angle? With 180 degree. Okay. But when a wave is get reflected with the free boundary, there will be a no change in the shape. Okay, but there will be a change in the direction of travel. Okay. Now, standing waves and normal mode. Now, why the standing wave will form? What is standing wave? The name itself suggests that a wave which is standing, not traveling. Okay. So we have two waves, traveling wave we have seen, the wave which travels from one place to another place. Now this is a standing wave, which means the wave which is stationary, not moving somewhere. Okay. And this wave you can easily observe when you tied up the string with your hand or with two supports and you give some disturbance to it. So you will easily see that there will be a wave generated in it, but it is not going somewhere. It is still there. Only the magnitude of amplitude will change with respect to time and the distance. So that particular wave is termed as the standing wave. Okay. Now we will introduce it in much better way. Yeah. So when two identical waves traveling in opposite direction, two identical wave we have, which travels in the opposite direction, okay, in the same medium, the medium will be same, combine and form a steady wave pattern. Why they will combine? They will combine because of the interference of the wave. Okay, because of the principle of superposition of wave. So when they combine, they will form a steady wave pattern. The wave pattern that is steady, that is not moving somewhere else. This wave pattern is termed as the standing wave. Okay. So in this picture, actually it is an emanation. So in this emanation, this red color dots, if you will see here, will represent the incident wave. Blue color will represent the reflected wave, and black color here will be represented the shape of the string. Okay. So now I'm playing it. This is a traveling wave, no doubt in that. Traveling wave is going, it's striking with a rigid boundary, getting a phase angle change with pi. Now we can say one wave is traveling in this way. After reflection, another wave is traveling in the same medium. We have two waves, same medium, but they are out of phase. Okay. And what is the definition of the standing wave? Two identical wave. The wave is identical, no change in the magnitude, traveling in opposite direction in the same medium, combine and form a steady wave pattern. Okay. So this wave pattern is known as the standing wave. Got it? Now, this is the traveling wave. After reflection, it is moving. Focus on this blue color. This is the reflection. So when they meet, the new wave pattern will be followed, and that will easily demonstrate by this black color dot. This wave pattern seems stationary to you, and that particular wave pattern is termed as the standing wave. Okay. And it has been formed because of these two waves traveling in opposite direction. This one. This one you can say a standing wave. This wave is not moving somewhere, but it is a wave. It is oscillating. This wave is termed as a standing wave. Now the equation of standing waves, y1 and y2 are the amplitude, sorry, displacement. Y1 is a sine kx minus omega t, which means the wave is moving in this way. Okay. And another wave, y2 a sine kx plus omega t, which means this wave is moving here to here, like in this way. Okay. So by the principle of superposition, you can add them up again, sine c plus sine d. So what you have this one. This one is the resultant wave. So if you compare this equation, this doesn't seem, we have seen that wave function y is given by ax plus minus bt. Okay, got it? But this wave function represents a traveling wave. Traveling wave. Okay. But here that wave, that resultant wave we have, it is not a function of something kx plus bt. It is not seems like that. So this function is a special function that represents a standing wave. Okay. So one of the important point to note down here that the wave which is standing or stationary wave, the amplitude of this stationary wave is not constant. Here, the amplitude is changing with the position. If you will see in the previous example, so here the amplitude we have is a function of x, which means each particle of the medium vibrate with the same frequency because omega is same. In the previous two cases, y1 and y2, omega is same. In this case also, omega is same, which means the frequency of vibration will same. But due to the change of amplitude, because amplitude here is a function of x. So if you will see, if you take this position and this position, so you will see there is a change in the amplitude. This particle is going only about this position. Got it? This particle has zero amplitude. This particle has maximum amplitude. Okay, so when we change the position, there is a change of amplitude. Now y is equals to 2a sine kx omega into t. Got it? Now, so I have told you that wave pattern has a variable amplitude, but there is no phase difference between particle oscillating in the same loop. Suppose if you will see, if you will take this particle and this particle, they are in the same loop, so they vibrate in the positive way. In the upward direction, they will move same with the same amplitude here and here also. The frequency of coming back is also same. So that is why we can say that for each loop, the particle that we have in one loop will have no phase difference in that. But if you consider one of the particle at this position and one of the particle in the another consecutive loop, so there will be a phase change of pi, because when it is in the upside, it is in the downside. So there will be a phase change of pi. Got it? In the same loop, there is no phase change. In the opposite loop, or sorry, in the consecutive loop, okay, there will be a phase change of pi. Now, if I talk about the difference, this is the standing wave. Sorry, this is the traveling wave. You can easily see something is travel in this direction. But if you will see this there is nothing that is going somewhere or coming somewhere. Okay. But obviously it seems a way because amplitude here is changing where it has a frequency. So this is a standing wave. Second is the disturbance produced in a region propagate with a definite velocity. We know that. Here the disturbance that is produced is confined to the region where it is produced only. Because here the disturbance is traveling from this point to this point, okay, here to here. But if you will see the standing wave, there is nothing going out and nothing going in. This is confined to this boundary. Okay. Third thing is the motion of all the particles in this wave, if you will see, are similar in nature. But if you will see this standing wave, there is no similarity in the wave pattern. This is oscillating with different amplitude, this is oscillating with different amplitude. So different particle oscillates with the different value of amplitude. Now, fourth point is there is no instant when all the particles are at the mean position together. If we will see, when this green dot, when this green particle, which is the source particle at mean position, there is hardly any particle which follow the same pattern if you will only focus on the green one. But if you will see in the standing wave, at some instant, they all particles at the mean position. Okay. First thing in this case, the energy is transmitted to one place to another place. But in the standing wave, energy is confined within the region. Okay. Now we will talk about the node. So have you observed one thing? When we discussing this wave, standing wave, so there are some point which never ever move from the mean position. These points, so they are not moving from the mean position. They are still there with the zero amplitude. It seems that there is no amplitude of these particles attached to this particle. And what are these particles? Don't forget these particles are at the forms because of the destructive interference. Got it? These particles where the amplitude of the standing wave is zero is termed as nodes. And when at that point where the magnitude of amplitude is maximum is termed as antinodes. This is the only definition of them. Then the standing wave, the point at which the amplitude is zero is called node or represented by capital N. These point, we can highlight these points. So the amplitude is zero. Amplitude of standing wave is given by this 2a sine kx. It is zero when sine kx will be zero. So we can get the general value of it. Sine kx is equals to 0. Kx is equals to 0 pi 2 pi n pi. So from here we can say x is equals to pi by k, 2 pi by k, n pi by k. So if you take the general value, x is equals to n pi by k, and put the value of k is a wave number here, x is equals to n pi 2 pi by lambda will go up, pi and pi will cancel out. So x here is given by n lambda by 2. So if you will put n is equals to 1 here, you will get lambda by 2, which means the difference between them, what is the value? X is the distance traveled in this direction. So between two node, there will be a difference of lambda by 2, where lambda is the wavelength of the standing wave. Okay. So if you will see, x is equals to n lambda by 2, the same that I have written here. N is 0, 1, 2, 3. So at n is equals to 0, you will get a node. At n is equals to lambda by 2, when you put n is equals to 1, the value of x will be lambda by 2. So at lambda by 2, you will get a node. So if you will see, from here to here, there will be lambda. This is the wavelength. It is completing one cycle. Okay. So node, if you will see from this point, is at lambda by 2. Again, it is at lambda by 2. Again, it is at lambda by 2. Although one point you can also consider that between any two nodes, there will be a path difference of lambda by 2. So the distance between two consecutive node is lambda by 2. Now what about antinode? So in standing waves, the points at which the amplitude is the largest are called antinodes and represents by A. So same thing. We have the amplitude A is equals to 2a sine kx. Mod I am taking because some of the particle is going in the down direction. Okay, almost all the particle. So that is why we have taken mod of it. Now, this would be maximum when kx sine kx will be 1. So it is 2a. Sine kx will be 1 when this value represented by pi by 2, 3 pi by 2, odd multiples of pi. So we can say it is n plus half, or you can say it is 2n plus 1 by 2. Same, if you compare this, you will get a value of x is equals to n plus half into lambda by 2. If you put n is equals to 0 here, because n always start from 0, 1, 2, 3. Now the distance between two consecutive antinode is lambda by 2. Okay. Now, what is normal modes? So in standing wave, if I talk about, this system cannot oscillate with any arbitrary frequency. This frequency by which a standing wave will vibrate will depends on the incident wave pulse and the reflected wave pulse amplitude or frequency. Okay, because it is the resultant of these two waves, incident wave and the reflected wave. They combine by the principle of superposition. There will be a wave pattern which results in some point, at some point it is constructive interference, at some point it is destructive interference. So with the help of that, we will able to find out what is the natural frequency of this standing wave. We cannot consider any arbitrary frequency because it is considered by a set of natural frequencies, and that natural frequencies are told as normal modes of the oscillation. Got it? So this we will discuss in the next class, how to find these normal modes for standing wave in the condition of string and in the condition of air columns. Mainly these air columns are also known as organ pipe. So we'll consider that also. And this we will discuss in the next class. Till now, if you have any kind of doubt, you can ask. Otherwise, you can leave the lecture. The lecture is being over. Thank you so much for your time. Take care of yourself. Bye.